Hey guys, we're actually going to be in section P3 today. We're going to do part 1 today. We'll do part 2 tomorrow. So we're going to talk about principal square root. Remember, this is going to be the non-negative answer. So square root of 81, we're going to wind up with 9. Negative square root of 9 is going to get you negative, and then square root of 9 is 3. Square root of 1 over 25 is the same as saying square root of 1 over square root of 25. Square root of 36 plus 64, we're going to go ahead and simplify that. 36 plus 64 gets me 100, and the square root of 100 is 10. Separately, square root of 36 is 6, plus the square root of 64 is 8. 6 plus 8 gets me 14. All right, moving on. So we're going to talk about the product rule, which again is multiplying. Understand if you have two numbers being multiplied, you can separate them as well under a square root. So you could say the square root of a times the square root of b instead of the square root of a times b. And it works both ways, whichever one's more beneficial to you. So this one, I don't know the square root of 75 off the top of my head. So I always say you want to think of numbers you know the square root of, like 1 times 2 times 2, 3 times 3, 4 times 4, 5 times 5. That's a good one right there. So instead of 75, I'm going to write the square root of 25 times the square root of 3. And the reason I chose 25 is because I know the square root of 25. So the square root of 25 is 5. I don't know the square root of 3, so I'm going to leave it alone. So we're going to leave that as 5 root 3. This one I'm going to go ahead and combine them. So if they're separated, you can also combine them. So we got 5 times 10, and x times x gets me x squared. And again, I'm going to separate it what benefits me. So if I'm looking at the number 50, right, I'm thinking of numbers I know the square root of, I'm going to rewrite it as the square root of 25 times the square root of 2, and I'm going to leave that x squared as square root of x squared. So we know the square root of 25 is 5. We know the square root of x squared is x. And we don't know the square root of 2, so we're going to leave it alone. So you got 5x root 2 as your answer. So again, that was the product rule. The quotient rule, again, you can separate them. So the square root of a divided by b, you can also write root a over root b. It also works in reverse, so it depends on what benefits you. So if you look at a, I want to separate those because the square root of 25 I know, and the square root of 16 I know. So the square root of 25 is 5, and the square root of 16 is 4, 5/4. Now here, I don't know the square root of 150. I don't know the square root of 2x. So it might benefit me to actually combine those into 1. So 150, 150 divided by 2 is going to get me 75. And then x cubed divided by x, remember when you divide, you subtract, so we're actually going to wind up with x squared. And now we can break that up. All right, I'm going to do 25 times 3, because again, I know the square root of 25, and x squared. So the square root of 25 is 5, square root of x squared is x, and I don't know the square root of 3, so I'm going to leave it alone. So sometimes it's beneficial to break them up, and sometimes it's beneficial to put them back together. So it just depends on the type of problem. Adding and subtracting. So adding and subtracting, you do have to have the same root in order to add and subtract. I always say think of it like x's. If I had 4x's plus 2x's, we would have 4x's plus 2x's, we would have 6x's. So in part A, if I have 8 root 13s plus 9 root 13s, I have 17 root 13s. So I always treat them like x's. It's kind of like combining like terms. Here, technically, you have 1 root 17x minus 20 of those root 17x's. So 1 minus 20 gives me negative 19 of those root 17x's. So again, make sure you have that root in common, a root 13 and a root 13, a root 17x and a root 17x. When you get to example 5, a root 27 and a root 12, you cannot combine those right now. However, they do simplify, so let's simplify them first. 27 I'm going to write as 9 times 3, because 9 times 3 is 27. Why did I choose those numbers? Square root of 9 is 3. 3 times 5 gets me 15. Still have the square root of 3. I don't know it, so I'm going to leave it. So again, square root of 9 is 3 times 5 gets me 15 times the square root of 3. Same thing for 12. I'm going to write it as 4 times 3. So the square root of 4 is 2. And I don't know the square root of 3, leave it alone. So now that I've simplified, I actually do have a radical in common. So I have 15 root 3's plus 2 root 3's. I have 17 root 3's. Next one, again, they don't look like they're the same, but we're going to try and simplify and see if it helps us. So here we're going to write 18. I'm going to do 9 times, and I'm just going to leave that x, 2x. 9 times 2x is 18. The reason I did that, square root of 9 is 3. 3 times 6 gets me 18. And I don't know root 2 or root x, so I'm going to leave them alone. Come over here to the 4, root. Now 8, I know it's 4 times 2, so I'm going to put root 4 and 2x, because again, that x is all alone. You're not going to be able to take a root of an x. So square root of 4 is 2. 2 times 4 gets me 8. And we haven't touched that 2x, so we're going to leave it inside. And now something that looked like you couldn't subtract, now you can. I have 18 root 2x's minus 8 root 2x's. So 18 minus 8 leaves me with 10 of those root 2x's. All right, so that was adding and subtracting. Rationalizing denominators. So a big no-no is you cannot have a square root. You can have a root. You cannot have a root in the denominator. So they call this rationalizing when you get rid of a square root in the denominator. What's the opposite, or how do you get rid of a square root? You square it. But you can't just square this because it's going to change the value of your number. So what we do is if we square this, we're really multiplying by root 3. If we multiply by root 3 on top and bottom, root 3 divided by root 3 is just 1. So really what I did was I multiplied this number by a really, really fancy 1. So I'm not changing the value, I'm just changing what it looks like. Now when you actually do it, you got 5 times root 3 is going to get me 5 times root 3. And then root 3 times root 3 is going to get me square root of 9. And you know the square root of 9, so don't leave it like that. We have 5 root 3. Square root of 9 is 3, and I don't see anything that simplifies because 5 is not divisible by 3. So we are done. Moving on to this one. There's 2 ways you could do this problem, and it totally depends on you. If you want to simplify, because root 12, technically you could do 4 and 3. You're allowed to do it that way. Or you can just simplify in the end. I'm going to go ahead and simplify at the end. So I need to get rid of root 12. Right? You can't have a root in the denominator. So I'm going to multiply. Oh, don't do it. Oh. Okay. I'm going to multiply top and bottom by root 12. So up top you have 6 times root 12. And I'm hoping we get to the point where we see, notice root 3 times root 3 was just 3, because we're getting rid of the square root. That's why we're squaring. So root 12 times root 12 is going to be 12, right? Square root of 144, which is 12. I'm going to go ahead and simplify the top. So 12 I'm going to write as the square root of 4 times the square root of 3. So the square root of 4 is 2. 2 times 6 gets me 12. I don't know the square root of 3, so I'm going to leave it. And I still have a 12 in the bottom. 12 divided by 12 gets you 1. So you have 1 root 3 as your final answer. All right, so that is it for this one. Stay tuned for part 2.